Hello everyone, welcome back to Dragonfly Engineering. So this week we're going to follow up on our robot end effector cube structure, and in this episode we're going to build the cylindrical standoff that is needed so that this cube is far enough away from the fifth axis of a robot where it doesn't actually roll up and gouge its corner. I can show you a picture of the orange robot next door. Anyway, so this should be a pretty simple process. And I think this time we're going to cover a little bit more of the cam process using Mastercam. I have Mastercam 2024 loaded, but I'm actually going to upgrade to Mastercam 2026 here pretty soon. So let's get into the process of importing the model of our cylinder, and we will machine this part on the Haas 5-axis UMC 750 milling machine. All right, so without further ado, let's dive into it. Okay, so we've got a blank interface here with Mastercam, and on the 5-axis Haas mill, I actually have a pre-existing fixture that holds stock, and this is a basic one that I machined in a previous episode, which is kind of just this trapezoid. And on the top is a bunch of quarter inch, 20 threads per inch set screws in a 1/2 inch wide groove, which I basically put T-slotted blank stock in. And that model actually exists. It was modeled in Mastercam. So in almost all cases where I'm doing 5-axis machining, I'll actually import the model of the mill table, the round table itself, plus the work holding fixture, and then I will merge in, as Mastercam calls it, the part that we're actually going to machine in this session. So I've got the screen recording, and what I will do is I will say File and Open, and we've got base fixture. So I will open the base fixture, and then here is the pre-existing fixture. So this is our mill table with the T-slots in it. And then we've got basically the riser block, and then up here is a red outline for the stock that was defined in the last operation, or the last part that was machined. So what I'm going to do is save this, File and Save As, and we'll go to the robot end effectors, and we will, instead of calling it base fixture, we will call it extension tube. Let me bring the keyboard over here. Okay, so that way we don't overwrite our original model of our work holding fixture. Okay, and then I will make sure it says extension tube. So now what we want to do is what's called merge. We're going to bring in the model of our extension tube for our robot end effector, and it's a step file. So end effector extension step is what we're going to open. Now, since we're in the merge function here, we're not actually going to open a new file, but we're actually going to import this step model into our work interface. Okay, and then somewhere in here it should exist. I think I see it, like inside. So now what we want to do is place our model. So we can say dynamic, and then we can drag with this little gnome thing our model out of the center of our fixture. Let's see if I can grab onto that guy right there. Hopefully it actually grabbed our part, and then we will zoom out with the mouse, and then bring our part up out of our work fixture, and I'll stick it right there. And basically we want the part to be tall enough off of our work fixture so that we can get a tool underneath it to machine it off from our teed-in stock, which is not quite accurate right at the moment, but we're going to have a 1/2 inch tab that goes into these set screw clamping positions. So to move this part some more, what I'll do is I'll click on this axis, the Z axis, and then I can drag the part while I'm dynamically zooming in and out. And we'll get a decent height. So that's probably good. Now if I wanted to rotate the part, then I can click on other features of this gnome This yellow dot is like dragging the whole center around. But I'm going to grab onto this arc section, and then we can roll our part around this way if we want. But we have a symmetric part, so we don't really need to mess with that because it doesn't really matter. So I'll hit escape, and then I'll hit the check over here. If I wanted to make more moves or move other parts around, I could hit the check plus and then it'll like accept this change or this move, and then I can do other motions as well. But I think we're happy, so I'll just hit check. And now our stock, or our part, is located on our fixture. So I'm happy with that. Now we can go over here to stock setup. And I believe in 2026, this whole interface for the stock setup is changed. So yeah, we got to keep with the times, I guess. All right, so anyway, it's showing the dimensions of our stock that's going to be loaded into our fixture. In this case, I'm going to change its location up and down. I guess I didn't need to do that, but actually what I want to do is change the size of the stock. So I guess origin, and then the actual size is the second settings. But I'm just going to click up and down on the entry point there to reduce our stock, mostly just so I get an idea of how big my base stock needs to be. That I'm going to rough machine on the manual mill and then load into our 5-axis fixture. All right. Keep in mind that we're going to have, oh, okay, I do need to raise the stock up. A T-slot on the bottom of this thing. Okay, so I'm raising up our stock, and that pretty much covers it. And I'm actually going to hack out this part here, but we don't need to show that for this setup. This is just to get an idea of the rough stock that we need. And then, okay, so I'm happy with the stock size, and then our outline for the stock is updated. Now I do want to move our part. I need to check to see what kind of stock I have out there, and I'm just going to use scrap chunks of aluminum and just basically machine the T in, so that, or the T-slot in the bottom, and then just hog out a bunch of just block scrap that's pretty much in the scrap bin at this point, because this is a small part. Okay, so it's possible that I will drag this part up and down more, and to do that you go to transforms and then dynamic, and then our little gnome comes back, and you can click on any feature like the center of this circle, but there's also a center of gravity, which is this little blue and white dot, and we can drag this guy up and down or left to right or whatever we want. We're going to machine one of these at a time, which sometimes is better in a 5-axis for more tool access. Whoops. All right, let's just go with that. And then we hit the check again. We're happy with that location. To clear the colors of highlighted like purple, you can right-click your mouse and then click this guy, and then you can see our colors. And I will make this opaque. It's a little tricky because the record bar is right there too. Oh, here we go. Okay. All right, so that's setting or bringing in our part into Mastercam and with a existing work holding fixture. So the next step is that we want to machine our part. So to the left is the toolpath group 1, and I'm going to right click and click mill toolpath, and I guess our first operation will be a contour. So this selection interface pops up, and there's different options. We can select a face or an edge, a partial edge, or a full edge. So I'm going to say we're going to select a full edge, and I'm going to come over with our mouse, and the white and black dotted line highlights, and we're going to click that as our profile that we're going to machine. Our planes, we can check either in the machining interface by looking at planes. And you can see that currently our work coordinate system, our tool plane, and our construction plane are all top. And top can be denoted by this cube down here, which tells you where top is in the machining operations. So in the 5-axis, if you want to rotate your part, 90 degrees, then you would start changing tool plane from top to front or back or right or left. And then basically your tool plane as well as your construction plane, you would update from top to, let's say, front, for instance. I guess we're going to do that at some point in this part, but this part is mostly cylindrical, so most of our machining is going to be where all the planes in the system are going to be set to top. But stick with this operation and you'll see how we will rotate the stock 90 degrees to basically part this cylinder off from the base stock, which is probably going to be the last operation for this cut. Okay, so top plane is set, and then what we're going to do is set our tool, since we've already set our profile. And if you want to see if your profile is selected, you can see chain geometry, we have 1 selected. And contour, again, is our operation. This tool library has been preloaded, but you can also search for a tool library with this mouse button down here. And in fact, I do not see tool number 7. So I'm going to load a tool library. Oh, actually, I think I've got a filter on right now. Huh. All right, well, I'm going to select tool number 7. I don't see it up here. All right, I will double click tool 7. Okay, there it showed up in our active tool list. Okay, so tool number 7 is loaded in the mill, and it's a 1/2 inch flat end mill. And then the feeds and speeds are also defined here. So I'm going to slow this down to 50 so we don't shoot the part off of our fixture, because it is just going to be tabbed down there, and we are going to do kind of a heavy cut. And 8,000 RPM should be good. So that's 50 inches per minute and 8,000 RPM. And then cut parameters. I'm going to turn the wear compensation off or to computer. And depth per cut is, these are settings to kind of limit the amount of cut that the tool path generator will take, so that you don't overload and cut too deep. So we're going to say 0.15 for our roughing, and then our finish cut will be 0.01. In this case, though, we're not going to really have a finish, so we'll just say 0, because we're just going to profile past this cylinder, past the bottom of the cylinder a little bit. Lead in and lead out, basically you can define how the tool enters your cut. In our case, we're going to do something interesting, which is going to be a profile ramp. And we're going to ramp at, let's say, a 4 degree. And this is kind of cool because the profile will just continue to go around your part and cut up to however the depth per profile. It's a helix profile that you're cutting. And you define that cut here. Breakthrough doesn't apply here. Multi-pass. We're going to do a rough cut and then a finish cut. So our finish cut is going to be 10,000ths of an inch. So we're going to do 1 rough and 1 finish. And I believe both of those will be with the profile cut. You'll see what I mean with a profile ramp here in a second. Linking parameters basically sets how deep of a cut you're going to cut, and your clearance planes and feed planes and everything. So depth is currently set to 0. But you can also click and define it. So by clicking, we just told the mill to machine this profile down 1.377 inches. But we want to go slightly past it, so we'll go minus 1.39 inches. And we need to make sure our end mill flute length is tall enough for that. But it's actually defined within the tool parameters as well. Okay, and then if we hit this blue check, we will see what our machining operation will look like. And it looks like the profile ramp only happens on the rough. So let's figure this out. Let's see here, multi-pass. Apply to all finish passes. Oh, okay, let's get rid of apply to all finish passes, and then we'll see what we get. Finish passes all depths, final depth only. And then we'll click, okay. So basically what's going to happen with this profile ramp is we're going to machine the face of this cylinder by spiraling down. So actually our machining operation, our hogging of the material, is all happening in just the tool entry. It's just that the tool entry is profiling our cylinder. And so you can see here, let's see here. Let me check on, let's turn off the finish and see what we get. Oh, something's not right here. Oh, I know what I need to do. Multi-pass, okay, back at depth per cut. In this trick, we're going to make the depth per cut the entire single cut itself. So we'll say 1.4. And then we'll hit the plus again. All right, here we've got a spiral profile, which is going to basically cut the entire face and then do a finished circle at the bottom. But our angle is a little too high, so I'm going to go back to cut parameters, or lead in and lead out. And our ramp currently is 4 degrees. Let's make that 2 degrees. And we'll hit plus again. And now we're getting more of a reasonable step over rate, because we don't want to spiral in too hard because we'll just gouge the tool and it'll be too much of a load. So maybe we'll do 1.5 degrees. And that's pretty much just like we're cutting a slope, we're hogging down into metal, except that that's wrapping around our cylinder. Okay, I'll hit plus again. Okay, so here we go. Now back in the previous cut that I had, let's just make this, divide this by 2, 0.7, or approximately divide by 2, and plus. Now you see how we would spiral down and then we'd do this blue actual profile cut, and then we'd come out or go back over to the next cut and then spiral down for our second blue cut. But you see this yellow line, which is actually plowing through our part? That would have been a tool crash, because under linking parameters, our retract height is not high enough. So we would have just retracted 1/4 of an inch from our cut and then plowed through our part to get to the next entry of the next cut. So we want to make retract height like 1.25 inches. And we'll make our clearance plane, just to be safe, 1.25 as well. And we'll hit the blue check again. And now you see that the rapid motion for the tool moving to the next cut location will raise up out of the stock and then over and then come down and then start its next cut. So you always need to check that you don't have rapid motions or rapid motions to your next cut cutting through your stock itself, because that would definitely bust your end mill off. But in our case, we're going to do the interesting technique of, let's see, depth per cut is going to be the entire depth. And our lead-in spiral is going to actually do all of the machining. That way we don't have any gouge marks from an end mill entering into the cut. After it did its first circle, it comes out and comes over and then leads in again. But every time you lead into a cut, you have the risk, because of tool flexure, of having a little line where the tool entered. By doing a continual spiral profile and then just doing the finished cut at the bottom, you don't have any tool entry marks or asymmetric forces on your end mill. It's seeing exactly the same force every time. So it's a good trick to do. So we'll switch back to 1.4 for the depth of cut, and now you can see we're going to enter our cut, spiral continually down, do a final cut, and then we're going to exit with that little red line right there. So that looks good, and then we can simulate this back plot. Okay, here we go. There's simulation as well where you can load stock, and we'll get to that in a minute. All right, so I'm just dragging the play button, and you can see it's a little difficult. Well, actually, let's see if we can just play it. This isn't like a true animation per se, but let's see what happens. Okay, so it's going to show the continual spiral as we're basically leading into our cut, even though it's actually doing the full face cutting of our cylinder as we speak. And I'll have to look at the definition of this end mill because it looks like it is, the way it's shown here in Mastercam, it looks like it'll gouge. So what we need to do is check the actual tool, and if we need to update the model of our end mill in Mastercam, then we'll have to do that. Otherwise, our tool holder may gouge into our aluminum stock. But anyway, that is the spiral entry for our cut. And after that, we will do some more profiling. So I think the next step, I don't think I'll show every operation here because this isn't like a rigorous Mastercam tutorial. But I think what we'll do next is drill these holes with, we'll center drill them, which is basically just to set the drill bit entry point, and with just a little dimple. And then we'll actually drill these holes as well. So let's do that next. Actually, I'm going to save this now. And extension tube is the file name, so we don't overwrite our base model. And I'll say yes. Okay, and then over here in the machining tree, we will right-click again, and we're going to say drill. And then it's going to ask us, what do you want to drill? So we're going to select these holes. There's all sorts of fancy ways to select holes, but to keep things kind of on an entry level, we will manually select these edges. If you select a face, then it's going to act differently. It's going to attempt to drill. Instead of your drill starting point being the top, it's going to say, okay, the full depth of this hole I want to drill. So you gotta, if you're going to select edges, you need to make sure you select only edges or only faces, because otherwise you're going to have various drill depths. If you select a face, the Mastercam says, okay, you're going to drill the full depth of this hole. So actually, your definition of the hole starts down here, where if you drill edges, then the start of your drill is up here, and then you define a depth. So make sure that you have solid arcs as selected for drilling. And then our process is similar as before, where I am going to select the spot drill, and it actually looks like it pre-selected it. And then we go down the list of things, basically cut parameters. In this case, we're going to drill. Your options are peck drilling or tapping and all of that, but we're just going to do a basic drill. And again, this is the top axis. So down here in the bottom right, you can see our current cutting planes are still all top. Linking parameters will determine the depth of your hole, and we're going to go 1.6 inches deep. And we will hit the blue check, which is kind of a preview. Oh, I see, I should have said minus 1.6. So definitely use this blue check a lot. Okay, and now I like the drilling preview in Mastercam. Apparently some people don't like it, but it shows you the retract location of your drill bit, the top of stock of your drill bit, basically where it's going to start thinking is drilling the hole, and then your depth of cut. And you can actually grab these flags and drag it up, and then they'll all follow in that group, which is kind of cool too. So you don't have to fuss about, oh, exactly how deep is my drill bit going to be and everything. And you can do the same with retract. So if you know, we're getting a little close to this machined edge here. So, and we haven't hogged away the stock at the top of our cylinder yet. So I'm going to drag retract up a little more just to be safe. And then they all follow, which is kind of cool. But you do need to keep track of order of operations here so that you don't wind up trying to drill into a hole that's deep in the stock before you've actually machined away that stock. So I'm going to go back and machine away this stock with the 1/2 inch end mill, but I don't want this video to turn into several hours. So And then, oh, wait a minute. Actually, we're just drilling right now. So we don't want our depth to be that deep. So I'm going to go back to linking parameters, and we're just going to make this depth minus 0.05. Now I've got two minuses. And we'll hit the plus. Okay, so now you'll see that we're just going to put a dimple in to guide our actual drill bit. So I'm going to say yes to that. And then we can also play this by saying backplot and play. Or actually, I'm going to drag this one so you can see the drill bit and how deep it's going to go. And you can change the transparency and everything. We can do that down here or here. Well, not that one. But here you can see how deep our drill peck is going to go. Okay, so now we're actually going to drill the hole. So I'm going to right click and I'm just going to say copy this milling operation, and we can paste it. And that way we don't have to re-click and select everything, but you can go in and edit the one that we just pasted. And in the parameters we can change tools to, let's say a 201 thousandths drill number 13, which is approximately 5 millimeters, which is the size of the hole that we are going to cut. This is a clearance hole for an M5 screw. Okay, and then we say, yes, we're going to use that drill bit, and we can go to our linking parameters and then update our depth to be minus 1.5, and we'll hit plus. And there we go. Now we have our drilling operation. But the drilling operation we copied is actually for a straight drill, not a pecking drill. So when you drill deep holes, you do need to do pecking, which is basically taking mouse bites of your hole so you can clear the chips out and so you don't jam up your flutes. So to change the drilling operation within this copied global or larger drilling operation, we can go to cut parameters and the little menu of options, and then we are going to say peck drill, and we're going to drill 0.1 inches per peck, and then we'll hit plus. And basically the preview is the same because we're drilling to the same depth, but now we're going to peck down every time. We can check that our tool clearance is kind of high right now. So under linking parameters, we have this 2-inch clearance, but we can make that 0.6 inches instead. We'll hit the blue check, and then that's a little more of a reasonable tool clearance. In fact, it's still kind of tall, but anyway. And then we will hit plus and green check that we like everything. And then again, we can play this operation with backplot. That's what they call it. And then we'll hit the play button, and we'll watch how the drill is going to peck drill all of our holes. Anyway, we don't need to say every one. Anyway, so that's drilling our holes out. Okay, so we are done with our drilling, and I did a couple of more operations off camera just to save some time since we're at like 28 minutes or so, where I copied and pasted the profile that we did and just cut this top boss right here. I also did some model chamfer as well as chamfering this corner. So the thing with model chamfer with Mastercam is it only the option model chamfer only chamfers sharp corners like this corner. But in this CAD design that was brought in, these corners were already chamfered in the model, and model chamfer doesn't do that. So I had to do a regular contour with the same chamfering tool. And let's play that real quick. So yeah, this is contouring with the tool, comes in, profiles, and obviously we got some issue. So I got to figure out what's up with that. I think I have to update the tool and tell them that it's only 20 thousandths in diameter because it's assuming it's using the side face, so I'll have to fix that. Anyway, Chamfering's kind of a hassle with Mastercam if the model's already chamfered. So maybe that's something to fix. Need to do the pocket, but I wanted to move forward with some of the more interesting things. One of which is I moved our part up in the fixture because of this interesting new scheme. The 5-axis, this is going to be a true 5-axis milling operation, not a 3+2, which is most of these operations. And 3+2 is, you know, you do 3-axis machining, but you rotate the part and then machine everything on that side, and then rotate the other way and machine everything with just 3-axis machining. With this contour 5-axis, which I basically did by clicking around and playing with it. You go to toolpath, and then in the multi-axis area, I selected curve and came up with this operation here. We can quickly go through it. Yeah, basically it'll follow a curve in space, which is kind of neat. So I did that, and I chose this curve right here at the bottom, because this boss is basically nestled up underneath our stock, and it's between our work holding and our stock. So the only way to machine this boss is to come in from the side, or do a second op with the lathe, or another CNC operation where you flip the part over. But the whole idea with 5-axis machining is you have only one setup. So yeah, here's some of the, I basically just clicked around until I got it to work correctly. And you'll just have to go through it yourself as well if you decide to get one of these. One of the things is I did multi-passes, 4 rough cuts, 0.1 inches deep per cut, and then a finished cut of 20 thousandths. So the result is this interesting toolpath. And what's going to happen is the mill is going to rotate the part on its side like this. And then when we play this operation, by backplotting and hitting play, you're going to see that the end mill is actually going to spin around this way. And actually the end mill stays vertical because our work coordinate system remained top, but this table is going to spin as basically we machine our boss underneath here. So that should be cool to see. But I did have to raise our stock up because otherwise our tool holder was going to crash with our work holding system. So let's play that again so you can see what I'm talking about. So the work, you know, if our part was down at the original position like here, then basically the ER collet holder would have crashed into our tool holding, or our work holding fixture right here. So we raised it up. Okay, so that'll be fun to see on the mill. So now one of the last operations, there's a few more things I need to do, like machine the pocket, but pocket milling is pretty similar to contour milling, so maybe I'll do that off camera. But we do need to tab off this part after we cut our underboss here. And to do that, I drew this line right here, and basically I did that by changing the cutter, or the planes, adjusting the planes. You can go to the bottom left of your workspace, and construction and tool planes I set to the front, while world coordinates system is still set to top. You basically always leave that at top. And now what I can do is, under wireframe, I can draw a line basically from one edge, whoop, oh, let's see, front, oh, okay, here we go, to the other side, like so. And then I use that line as a feature, or we can do that now actually. So under toolpath, we will do a contour, and we are going to select a wireframe and a partial, and then I will select this line right here. So the green arrow means start here, and then the red basically means stop here, and that's the direction of cut that we're going to do. And our tool plane, or our viewpoint of the tool is this direction right now. So that means we want to cut on the right side of our line. So okay, we're happy with that. And then we'll go through basically the same kind of profile, or the same list of questions. So we want to use tool number 4, the 1/4 inch, and depth of cut. We want to turn that on. Lead in and lead out. We want to do, we can do tangent, and but I'm going to add like 200% of the tool diameter for the lead in, and then the radius will be 0 because we want a straight line cut. And then you can hit this double arrow down here to move all of the settings over to the lead out as well. Multi-pass will turn off. I guess we could do, for demonstration purposes, we'll leave it off. Depth per cut is on. Oh, let's see, for a finish, we'll do one finish, because we are going to be coming up on what we're doing is we're machining both sides of the stock under our part and just leaving like a little leaf of metal, like a tab is what it's called, that you can then break off with your hand when you're done. And until you cut down to the final bit of metal, the part is still held by the chunk of metal that's left. But as you get down closer and closer to that leaf, you need to back off the aggressiveness of your cut, otherwise your part may just shoot off. So that's why we're going to have a finished cut of 20 thousandths here. Okay. And then linking parameters. So basically all the other settings were just guidelines for, or limits and settings for the actual meat and potatoes of your toolpath, which is all done in linking parameters. That's where you say, I want to cut 1 inch deep and I want the tool to clear by ½ an inch or something. So most of these are just settings, but linking parameters is where you actually make it happen. Now what we're going to do, since we want to leave a tab, and I drew that line at the 0 bisecting plane of the part, instead of making the depth a minus number, we're going to make it a positive number. So we'll make it 10 thousandths positive. And yeah, so that should do it. Feed plane, we'll see, I guess now that'll just be 0.1 above the actual stock. And we'll hit the blue plus and see what we get. And we just got 1 pass there. Oh, because the top of stock is set to 0. So basically Mastercam said, okay, well your stock is at the line, so I'm just going to do a single cut. So we have to tell it. I guess it's not quite smart enough to recognize this solid up here, but maybe if I was better at this, it would. But we're going to say that the top of stock is 0.8 inches. And now if we hit the blue plus again, you'll see how it said, oh, okay, I'm going to follow the rules that you said, but now the top of stock is out here somewhere. So I'm going to go ahead and cut my first pass and then come out. And I think this looks good. So let's play this with the back plot and see what we get. Okay, so here's our tool coming in from the side. The orientation in the mill will be more like this because our spindle is always vertical. And then we'll hit play and see what happens. All right, so we come out, we make our next cut. We come out, make our next cut. And yeah. Now again, if I needed to spend more time, or if I truly didn't have to do any finishing on this part, then like polishing with a lathe or whatever, then I could do a finish cut as well, but it would just take twice as long to cut this thing off. Now we're only cutting to halfway down, minus our tab height. So this green dotted line is the actual center of our part, so we're leaving a little bit of metal. So now what we can do to basically cut away the other side of our tab is to simply just copy and paste. Oh, you know what? I was putting this contour in the wrong location. So I'm going to move the green arrow or this red arrow down because we don't want to cut our part off before we're done machining it. So I will drag and drop the contour and say move after. Okay, so here is our finishing contour. And now what I'm going to do is I'm going to move our little red placeholder to the very bottom of the stack. I'm going to copy the contour we just did, and I'm going to paste it. And now we can go in here and change these numbers, mostly just the construction and tool plane and the handedness of the contour cut to be the other side. Since we're moving to the other side of that same line on the back side, we need to switch from left to right. So let's do that first. So cut parameters, compensation direction is right, and we're going to switch to left. And then the planes we have to change too. So we can change that here within the toolpath program itself. Right now we're on front plane, and if you look at our little box here, it says front is up. Well, now we want to, since we're cutting the other side of our tab, we want to switch this guy to back plane. So I'm going to click back and then hit yes, okay, and then we can hit the double arrows to move that setting over to cutter compensation or construction plane as well. And then we'll hit plus. And all of a sudden our second cut is got the right-handedness and it's on the back side. So the mill will rotate the part 180 degrees and then repeat our cut. And at the end we're just going to have our finished part hanging on with like a little tab of metal right here. So I'm going to finish the pocket, and then we can go out and machine this thing. Or I may have been showing segments of this within the tutorial, the Mastercam tutorial, but maybe at the end here I'll just do a super fast elapsed time machining operation of the whole thing. Not sure yet. Okay, let's do it. All right, let's break this thing off. There we go. One finished part. Oof. Might have to do a finish. Slow down the radial cut on the bottom. And I'll need to clean off our break-off tab as well. But looking pretty good.